Hi everyone, welcome back to our video. Today we are going to talk about series and parallel circuits. If you haven't watched our previous video about Ohm's law, please do it so as it is related to this video. So, what is series and parallel circuits? Well, they are basically ways or paths that you can connect more than one electrical component together. Series and parallel are two of the most basic ways to connect these components. When you have a lot of components, you can also connect them in a mixture of series and parallel, as well as ways that are neither series nor parallel. That's why, before we go into any calculation, we have to first learn how to tell whether the components are connected in series, parallel, combination of the two, or none of the above. To determine which type they are, you have to first determine the start and the end of the circuits that you are examining. When determining this type of connection of the components, the direction of the current doesn't really matter. Hence, the start and the end can be the other way around as well, as long as the current moves from one point to another. If you have an incomplete circuit that you will need to check whether they are series or parallel, usually there will be two paths where the wires stop, which become a terminal. These two terminals will be the start and the end respectively. If you have a complete circuit with power source, you will usually take the terminals of the power source, which is the positive and negative end of the power source, as the start and the end. After that, all you need is a pen, or better, some pens of different colors. Now back to the two circuits that we have identified the start and the end. The rule is actually very simple. For series circuits, from the start to the end, there is one and only one path without any split, meaning that all components connected in a series can be stringed together in a single line, or with the pen in your hand, you can draw a single line from the start to the end. This should be the rule of thumb when determining if a circuit is series. If there is any split anywhere, it is not series from the part that it split. As for parallel, the general rule of thumb is that the path will split and then will meet again. Which means, if you have pens of different color, you can start drawing using different color for each path, but in the end, all color must join together at a single point. This is applicable if there's multiple split as well. As long as all paths split before they go through any component, and then meet again at the same point, or along a short path without any component, then each component on the path are parallel to each other. When we talk about series and parallel, we are actually referring to the components that we pass through. This is very useful concept when dealing with circuits that are a mixture of the two. Let's say we now have a circuit that look like this. To make it easier, I've already named them A to E. If we now start to draw line, we will pass through A first before heading to a split. Now the path on the left will pass through B and reach the meeting point. On the right, the path will pass through C and D before reaching the meeting point. Then, the two paths will join, cross through E at the end. So how do we deal with it? Basically, we can say that C and D are series to each other. The combination of CD, let's call it CD, are parallel to B. Then, the combination of B, C, D are series to A and E. Now, on to the calculation part. To understand the calculation bit, you will need to understand what are voltage, current, and resistance. So if you haven't watched our video on Ohm's law, make sure you did. From our last video, we say that voltage is like the energy that pushes the current. The property of voltage in a complete circuit is that it will be consumed when passing through a component. And 2, it must be fully consumed when the circuit loops back to the source. And 3, if it passes through a split, each separated path will have the same voltage. So we now look at simple series circuits that has multiple components. We can conclude that the voltage drop across each component when added together must be equal to the total voltage provided by the source. As for simple parallel circuits, each path will have the same voltage so that the component on each path will consume the amount equal to the total voltage. As for the current, we previously said that they are basically particles that passing through each component. Since we can't create or destroy particle, the amount that loop back to the power source must be the same as the amount that left in the same period. With this in mind, we can conclude that the same amount of current will be passing through all components in series. When the path is split, the current will be split too, but the sum of each path must be equal to the total current. Now it's time to talk about the resistance. The resistance is actually the key in calculation. Let's say when we have a simple circuit with a power source of known voltage, it is connected to 3 components, each of same resistance in series. How do we calculate the amount of current? In each circuit, there is actually another property, that is, the equivalent resistance. In this case, for example, to get the amount of current, we will actually need to find the equivalent resistance, sometimes known as total resistance, of the 3 components, so that we can calculate the current. If you think of it this way, in a circuit of fixed voltage, if we keep adding more components of the same resistance, the amount of voltage passing through each one will be decreasing as well. Since we know that current is equal to voltage divided by resistance, we know that current will decrease proportionally with the voltage. Another property we knew was that the current will be the same for all components in a series circuit. Hence, the decrease of current passing through an individual component implies that the total current is decreasing as well. Using some mathematical deductions, we can conclude that the equivalent resistance of components in series circuits is equal to the sum of resistance value of each component. As for the parallel, we have to calculate the equivalent resistance as well. However, the deduction of the formula is significantly harder than series, so I will skip it for now. The formula for calculating equivalent resistance when the components are in parallel is as follows. Basically, the reciprocal of R equivalent, or basically 1 over R eq, is equal to the sum of reciprocal of each component resistance. For any circuits with only 2 resisting components, however, you can quickly calculate it by multiplying the value of 2 resistance together, then divide by their sum. Finally, multiple power sources, such as a few batteries, can be arranged in series or parallel as well. For batteries arranged in series, which means if you line them up end to end, the voltage provided will be the sum of each individual voltage. If you connect batteries of same voltage in parallel, the total voltage provided will be the same as each individual voltage. However, the advantage of connecting this way is that the battery, if used on same component, will last as many times longer as how many batteries you have used. That's all for this video. On our next video, we will talk about how to do calculation on circuits that has mixture of series and parallel, and then the pros and cons of series and parallel connection. Thank you. See you next week.